Fairly simple one. What are the units of torque? Now remember, if we look at the formula for torque, it looks something like this. Torque equals force times distance, where if we have a spanner or something, the distance is the length of the spanner, or the distance at which we're pushing it, and the force is how hard we push on it. So from this we can actually work out the units. Force is in newtons, and the distance is in meters. So torque must have units of, that's right, Newton meters. Not a very common unit, especially not in high school physics, but we can get used to it. Question 14. Why do we use electromagnets instead of permanent magnets in motors? Alright, so we have a few options here. The field produced by permanent magnets is not uniform. It is difficult to produce radial fields with permanent magnets. Electromagnets produce stronger magnetic fields, or electromagnets are much lighter than permanent magnets. So our answer here is that we want a very, very strong magnetic field across the motor. And it is possible to produce strong magnetic fields with permanent magnets. However, it's much easier to produce strong magnetic fields with electromagnets. So, C is the correct answer. D may also be true, depending on the size of the permanent magnet. Radial fields don't really relate to the problem of motors, and the field produced by each sort is about as uniform. The main reason is because electromagnets tend to produce stronger fields. Question 15. A galvanometer is recording a constant current flow. Which statement about this galvanometer coil is correct? The torque on the coil is 0. The torque on the coil is larger than the restoring force in the spring. The torque on the coil is less than the restoring force of the spring. Or the torque on the coil is equal to the restoring force of the spring. The term restoring force should really probably be restoring torque, but you get the idea. So, the torque on the coil is 0 would be true if there was no current flowing. However, because there is a constant current flow, we know that there is torque, so it can't be A. Our question then is whether the coil is moving or not. If the coil is moving upwards, then that means that the torque on the coil is larger than the restoring force. If the coil is moving towards 0, that means the torque is less than the restoring force in the spring. But because it's not moving and it's recording a constant current flow, our only answer is D. The torque produced by the magnetic force on the galvanometer is equal to the restoring force of the spring that it contains.